Fundamental identity states that sine squared of alpha plus cosine squared of alpha is equal to 1. Then we have reference angles. These reference angles falls on the Cartesian coordinate, which is also part of the unit circle. These are quadrant 1, 2, 3, 4. Definitely make a little note on this one here. This will help you throughout the course. It's going to be easier for me to use it as an example than it would sit and go over it. So this page here is going to be really good information for you. It has the theorems and it has more reference angles. So let's start on example 1. Example 1 just asked us, what is the identity for sine squared alpha plus cosine squared alpha equaling 1? Well, we just saw that it's the fundamental. All right, so that one wasn't too bad. Let's do example 2. Example 2 says find the exact value of sine alpha given that cosine alpha is 5/11 and alpha is in quadrant 4. So that tells me if alpha is in quadrant 4, let me find my pen real quick. In quadrant 4 here, then I know that cosine is positive and I know sine is negative. Okay. So to solve this fundamental problem, we know the fundamental of sine squared alpha plus cosine squared of alpha is equal to 1. Since you already know what cosine alpha is, then we can find its identity. All right, so let's use that sine squared alpha. Oops, I meant to put a plus sign. Well, we know what cosine of alpha is. We know it is 5/11. So I'm going to write it right here. And that's all equal to 1, right? So now all I have to do is get the sine squared of alpha by itself and then go from there and to get alpha by itself to find, or to get sine alpha. All right, so first things first, we can either square this 5/11 and then move it, or we can move it and then square it. It's up to you. I'm going to go ahead and square it and then move it. So I know 5 squared is 25, and I know 11 squared is 121. And I'm going to subtract it from this side, and what I do to one side, I do to the other. All right, so now I'm happy because this here went to 0. All right, and now I got sine squared of alpha is equal to 1 minus 25, 121. However, we want sine of alpha, not sine squared. To undo that square, that means I must take the square root of both sides. In algebra, we go over this about the roots. And whenever we talk about links, we don't always apply this next thing I'm fixing to tell you, because we're not going to say we're going to have a negative link. But whenever we take the even root of this side, we have a plus or minus value. If it was an odd root, we'd only have the positive. However, most of the time, if you notice through my lectures over some of these sides, we don't focus on that because of the fact you're not going to say you have a negative link. However, in this case here, we need to recognize that we have the plus or minus. Why? Because they stated the fourth quadrant, so it does matter. So now I'm going to have sine of my alpha plus or minus the square root of 1 minus at 25, 121. So we can clean up the inside of that radical. Go ahead, and if you want to use a calculator, or you can use paper and pencil, in order to add or subtract fractions, you have to have a common denominator. And in this case here, the common denominator would be 121, and then you can clean it up and then do your subtraction. But I'm going to leave it in fraction form for right now, because what do I know when I do this? After I clean it up, I know that my denominator is a perfect square, so yay. And plus, we're not supposed to have a root in the denominator as our final answer. So I'm going to take the square root of 96 and square root of 121. I get plus or minus. Well, the square root of 96 is going to be 16 times 6. And let's just write it. 16 times 6 over, well, square root of 121 is 11. We already knew that because we did that up here, right there. All right, this is going to equal, well, the square root of 16 is 4. And then, of course, 6 doesn't come out of the root. And then we're left with this as our final answer. Now, before I make my final statement, I go back to this statement here about the fourth quadrant. And I know that sine is negative in the fourth quadrant. So I know my answer is sine alpha negative 4 square root of 6 over 11. Okay. So let's do number 3. Number 3 states that we're going to find sine alpha given that cosine is 1/5 and sine alpha is greater than 0. So then that means it's going to be positive, right? Because any number greater than 0 is positive. Okay. So let's find it. Well, we're going to apply the same rule again. I got sine squared of alpha, and you can use parentheses on alpha or you don't have to. You'll notice I do off and on. I know what cosine of alpha is. It's 1/5, and we're going to square it, and it's all equal to 1. So 1 squared is 1, 5 squared is 25. I'm going to subtract it from both sides. And now I got sine squared alpha is equal to 1 minus 1/25. If y'all want to clean this up now, you can, or you can wait. It's up to you. I'm going to, just because I know what's going to happen to that denominator. All right, now, in order to get sine alpha, I need to take the square root of both sides because I got to undo the square, right? And remember, we got plus or minus because it's an even root. However, this said here, sine is all numbers greater than 0. So I know that I'm only going to focus on the positive. So you don't have to write positive because we know it's there. So I got 24, square root of 24 over square root of 25, which is equal to, well, what is the square root of 24? 24 is 6 times 4 over, well, square root of 25 is 5. Square root of 4 is 2, and 6 doesn't factor out. So that is my end answer. Let's look at the next one. The next one is asking us to sketch this angle. So we're going to sketch the given angle in a standard position and find the reference angle in degrees. So they said we have 330 degrees. Well, a complete circle is 360. So if I was to subtract that 360 minus 330, I know that I got 30 degrees, right? So that's my reference degree angle. So I'm going to go find my 330 degrees. Well, we know that it's going to be in the fourth quadrant because it's going to end, right? Because 270 is right here and 360 is right here. So it's got to be this one. So C is the correct answer. Now, we want to obtain the this angle in radians, okay? So we're going to multiply the conversion factor that changes the degrees to the radians. So we know that we have what, 30 degrees? Make sure, where's my pen? 30 degrees. And we want to put it in radians. So we're going to do basic conversion. We need the degrees to reduce. So I need the 180 on bottom. I want it in radians, so I need the pi on top. So now I'm just doing the extra steps. You don't have to. The degrees reduced. If you notice, I'm not writing them now because they actually reduce with each other. Now I can reduce the 30 and the 80, right? Or 180, sorry. 30 goes into itself once, and 30 goes into 186 times. So I'm left with pi 6. So this is my radians. My degree measures in radians. Okay. Let's talk about number 5. Number 5 says sketch the given angle in standard position. All right. So it's helpful if you use a unit circle to find 2 pi thirds. If you find 2 pi thirds, you'll notice where it would be at in the second quadrant. However, it's got a negative value. That means it went backwards instead of forwards. See, it would fall here if it was positive. And since it's negative, it's going to fall right here. So A is my best option. And now what we need to do is find the reference angle. Well, I do know that, okay, we got 2 pi thirds is what we're working with. And we say that we're going to do some math right quick. We can subtract that from pi. So we came from this direction. So I'm going to say it's going to be 2 pi. We're going to take 2 pi minus that. I'm going to write it like that because we need a common denominator, which is 3 in this case. So now I got 6 pi minus 2 pi all over 3. This gives me, what, 4 pi over 3. So that should be my reference angle. If we did, let's look at it this way though, but that's going backwards, so that would have gave us another value. So let's look at it another way. So if you do it this way, you will yield an outcome of this, and that's going that direction. However, if you notice, it fell in quadrant 3, but it originally belonged in quadrant 2. We're closest to pi, so let's just try subtracting it from pi. We need a common denominator. In this case, it's 3. So now I got 3 pi minus 2 pi, and this is going to be pi over 3. So this is going to be the actual correct one. Okay, so just a little side note. If our reference was in quadrant 4 or 1, we would use this method. And since it's in quadrant 3, originally 2, and then we took the negative of it, is quadrant 3, we use this method. So my answer would be pi over 3. Now let's take the pi over 3 and let's put it in degrees. So again, we want the radians to reduce. So I need the degrees on top. The pi's reduce, the radians reduce, leaves me with 180 degrees divided by 3, which gives me 60 degrees. And that is my conversions, radians to degrees. So let's talk about number 6. We're going to use the reference angles to find the exact value of the following expression. Well, if I take my calculator, well, actually you can go to the unit circle, find 330 degrees and look at the order pair for cosine and sine and what is sine. If you do that, you're going to see that it's a negative half. If you want to, you can go to your calculator and it's going to give you the same value. And you can use the calculator to check your answer. However, memorize that unit circle. This would make it easier, and it's better for you to know it. And use the calculator to only check your work, not to give you the answer all the time. Okay. All right. Example 7. Use the reference angles to find the exact value of the following expression. We have cosine of 5 pi fourths. All right. So we can use the identity rule to find that. Again, I'm going to plug it in my calculator. I get 5. I have to use the shift for my pi over 4 and close parenthesis, and it gave me a decimal. So that is not exact. Okay. So let's go to the unit circle, right? You go to the unit circle and you find its order pair and find where it falls at 5 pi over 4. You're going to find out that cosine is negative, and remember, in the order pair, it's cosine, sine. So you're going to definitely want to use your unit circle. So you're going to find out that it's negative, and it has got a reference of square root of 2 over 2 in the order pair. So that is the answer. Okay. Well, we're going to use the reference angle to find this next one, right? We have cosine and one second, come back up here. I wanted to tell you that, well, no, just memorize the unit circle and use the calculator and check your work. You're better off that way. There's a lot of neat little tricks, and as you're learning, you're going to figure out ways that work for you the best. All right, so on this next one here, we're going to find cosine of negative 135 degrees. Again, that means the circle went the opposite direction. And we're going to find its reference. So I know that where 135 degrees falls at on the unit circle, but since it's negative, we're going to start the other way, and we're going to find its terminal side. And when I do that, I find out that cosine is negative, and I find out that the square root of 2 over 2 is its exact value. Okay. And reach out to me if you want to work some more of these out, and you can go over the actual unit circle. Okay, so let's do this next one. A weight is suspended on a vertical spring. The position x of the weight on the vertical number line is given by the function x equals 3 sine t plus 4 cosine t. Where t is in second, the vertical number line is given by the function, and we're given that function. And we're going to start with when t is 0. Well, that means time starts out at 0, right? When we're starting things start at 0. So we're just going to plug in 0 for t. All right. Well, sine at 0 is 0. Cosine at 0 is 1. So 3 times 0 is 0, plus 4 times 1 is 4. My answer is 4. Okay, now let's find part B. Part B says find the exact position of the weight when the time is 7 pi fourths. All right, so now we are going to plug in some other value other than 0. So we're going to take the x equals 3 sine 7 pi fourths plus the 4 cosine 7 pi fourths. All right, well, we need to know the exact value of sine 7 pi fourths, cosine 7 pi fourths, and where it lies at. Well, I got a diagram here to help illustrate where it's at. Right here, see it? So now we know the angle, and now we need to find its exact value at that particular point. Well, this is going to give me 3 times, well, the exact is a square root of 2 over 2, and negative square root of 2 over 2. So the exact value from sine is negative square root of 2 over 2 plus 4, and then the exact value of cosine is square root of 2 over 2. And now we're going to do multiplication. So it gives me a negative 3 square root of 2 over 2 plus, what happens to that 4 and 2? Well, you may want to go ahead and reduce it now. That's okay. But remember, we're working with fractions and adding and subtraction. So that means you'll have to put that right back in, all right, in order to add or subtract. So you notice that the denominator is identical. Okay, so we're good there. And in order to add or subtract anything, they have to have common terms. And this has a square root of 2, and this has a square root of 2. So they are common terms. I'm going to write one extra step. You do not have to write it this way. I just factored the square root of 2 on the outside and said I got negative 3 plus 4, which gives me square root of 2 over 2. And this is the exact position.